Good morning, everyone. Welcome. I'm Stuart, the Exam Solutions guy. Do all the videos on ExamSolutions.net. You might have seen them in the past. So we're back here again for another workout. You might have just seen the program of things that I'm going to be doing in this live stream. We're going to be looking at integration, parametric equations and mod equations, and I'll be throwing in hopefully a few tips on the way. They're going to be exam questions and they're structured from AS up to A level, but even if you're an AS student, I hope that you'll get some value from them, whatever. Okay, so just a few things that I want to say. I can see a lot of you, the regulars, are back on, so welcome back to all of you guys. I think there might be a few new ones out there, so welcome to you all. I know that Michael's online. He gave us a thumbs up earlier. Welcome, Michael. And Michael will be doing the live chat while I'm giving the live stream. And he's here to help you along your way. Okay, so any questions, just ask him. That's Michael from Air Maths Tuition. And Michael, by the way, is giving some presentations, live stream presentations next week. So he's going to be concentrating on algebra on Monday. On Wednesday he's going to be doing shapes and geometry, and on Friday stats and probability. At GCSE level, by the way, that's going to be covering foundation and higher. So if you've got any brothers, sisters out there, or even you yourselves want to come back and have a look at those, it would be great to see you, and I'll most probably be on the live chat end next week. Okay, so yeah, so I'll put out a few more reminders as we go through the week. Anyway, so hopefully you got pen, paper, calculator ready, and we're going to get started on this workout, about 30-40 minutes long. Okay, so here we go. Okay, so let's just take you over to the first question. There's three questions here, by the way. Several have got parts to them, but we'll start with the first one. It's just a single question. We've got here f dash x, or some of you might call it f prime x, is equal to all of 2x minus 3 over x all squared. And we're given that f of 3 equals 2, and you've got to find f of x for 4 marks. Okay, this, as I say, was taken from an exam paper. It's an AS style question, and if you're a regular here, you'll know that you can just work this out, try and work it out, and start to give me your answer. Okay, when you're ready, I'll tell you what we'll do today is we'll just go for that constant. Okay, we'll go for the final answer, I'll give you that, but so it makes it easier to enter in, just give me the value of the constant when you work it out. Okay, just enter it in. So I'm looking for that constant. So his first question, if you're just joining us, is an AS question, although if you're doing it for A level it can appear on the A level paper, but it's basically an AS question. So already by now you should be thinking of expanding those brackets. And I'll give you a few more clues just in case you're struggling. You should be basically ahead of me by now, but if you've expanded the brackets, you should be preparing it for integration to get back to f of x. Okay, when you're given basically f dash of x, or equivalently dy dx, and you want to work backwards to what y is, or f of x in this case, you've got to start to think about integrating it. So remember, we're looking for, I'd like the full answer, but just so I know you're on track, if you were to enter the constant that you find, that would be good, okay? Right, we're getting an answer for a constant. C is 17 from Ragalan. I hope I've got that right. We've got another one value coming in from Din. C equals 3, is that? Or is it negative 3? Can't quite read it here. Okay. Rahima coming in with full answer here. Interesting results. So, okay, so what other constant values have we got coming in? Jasmine with a constant C equals 5. James is giving me a full answer. Whether that's correct, James, we will find out later. Okay, it looks like a lot of you are starting to complete this. Well, I'll give you the answer. Well done. The constant is 5, okay, if you got that. And as for the full expression for f of x, you'll see it is 4x cubed over 3 minus 12x minus 9 over x plus the constant 5. And you can have it in any order, okay, as long as you've got those terms. What I'll do though is I'll just quickly run through it just so that you guys can see how it's done, how I've approached it. Okay, I've copied down the question, as you can see, written the bracket out twice, although many of you should be able to just expand it without writing it out like this. When you're expanding brackets that are squared, all you've got to do is square the first term, which is the 4x squared. I always do twice the product of these two terms. So if you were to multiply them together, you're going to get minus 6 because the x's cancel, and you double it, and that will give you the minus 12. It's the result of doing this term with this term, or that pair I should say, multiplied with that and that pair there. And then you square the last term, so it's going to give you 9 over x squared. Okay, we need to prepare this term for integration, so I bring the x squared up. You should know your negative powers. It becomes plus 9x to the minus 2. And then we're ready to get f of x just by integrating what we have here. Remember to put this in brackets. You've got more than one term there. You're integrating it with respect to x if you're doing it in an exam. Okay, I know you might be rushing through this to get an answer. Okay, integrate all the terms in the usual way by adding 1 to the power and dividing by your new power. So you're going to get 4x cubed over 3. When you've got a constant, it just is the x added on the end, so you get minus 12x there. And for this one, add 1 to the power, x to the power minus 1, divide by that new power minus 1. Not forgetting your constant c. Simplify this, and you're going to get this term here is minus 9 over x. Okay. Then we need to work out the constant c, and we're given that f of 3 equals 2. In other words, when you substitute x equals 3 in here, it should come to 2. So you can form an equation. There it is there. Okay. Simplify this, and you'll get this result. And it cleans up very easily because those 36's cancel. Add 3 to both sides, and you've got equals 2 plus 3, which is 5. Finish the problem off, okay, and by substituting c equals 5 back up into this equation, and you've got f of x, okay? So that's the kind of thing that I would lay out in an exam situation. That idea of showing a fair amount of working out, okay, so the examiner can see how you've approached the question. So that's just a guideline, okay, so I hope that's given you some idea. So well done to all of you out there who managed to get that, okay, that constant c equals 5, and also to get f of x. Okay, we're going to move on now to the next question. So that was an AS style one. We're now moving it up to another one, a question that I've not given in any of these kind of workouts so far. We're going to be looking at parametric equations, okay, and I'll drop a few clues on the way as you get going on this one. Okay, so we've got this curve. It has parametric equations, x equals t plus 2 over t and y equals t minus 2 over t. T's not equal to 0. And for the first part of this question, there'll be more coming later. We've got to find dy by dx in terms of t, giving your answer in its simplest form, okay? So you've got to make sure you give it in its simplest form. So there's a bit of a clue there, how it might start to work out. So hopefully you're on your way with this one now, okay? Finding dy by dx in terms of t, giving your answer in its simplest form. And I'll be looking for that simplest form, okay? When you feel that you've got it, just enter it in, okay? You've got to enter it in, let's say you've got to enter it in properly, okay? I'm going to be very strict on the way you enter this so that I can say whether you've got it or not, okay? Because you've got to enter it in obviously on one line here, okay? So good practice as well in entering your result in as a result in one line. Okay, so as I say, this is an A-level style question. On parametric equations. You should see some video tutorials on my website on this, plenty out there on parametric equations. And finding dy by dx is often the very first thing that you're asked in exams. Very common type of question. So by now you should be, I'm going to give you a clue here, you should be knowing this step here, that you're going to need the chain rule, okay? In case you're wondering what to do. Dy dx is dy by dt times dx by dt. Effectively, no it's not. I made a mistake there. Oops. Okay, sorry guys. Let's just remove that, okay? Spot the deliberate mistake, eh? Should we just change that? Okay. Right. I did mean to say dy dt times dt by dx, okay? I try and check these the night before actually, and that's a careless mistake. And it's the same as dy dt divided by dx by dt, okay? So there we go. So you should be working through the chain rule to get that dy by dx. Okay, we're coming in. Din's got an answer. He's got an answer. Let's see if anybody else agrees with that one. Okay, Rahima coming in with an answer. Interesting answers. Do read the question carefully. Okay, there's a bit of a clue there. Do read the question carefully. One of the reasons why I picked this question was because of this ending. Okay, again, dropping clues. Anybody else? Okay. That clue is the simplest form. Okay, we'll just wait a few more seconds. We'll go about another 15 seconds. Okay. Interesting to see some actual values coming through here. 0, -1. I must admit, I'm not too sure where you guys are getting those answers from. Okay. I can see Happy Gaming's got 0 on there. I like to think that I can figure out how people got these answers. I think I might have guessed. I think you might be trying to substitute t = 0 into your answer. Maybe I'm wrong. Anyway, let's go through this, okay? Just by the way, t isn't equal to 0. The reason that is so is because the x and y coordinates would be undefined at this stage, okay? If you divide it by 0, you get an undefined value. Right, let's take you through this though, okay? I've copied down my x value, okay, as t + 2/t, and I'm going to be heading towards this idea here. dy dx by the chain rule is dy by dt divided by dx by dt. So I'm going to need to differentiate these two equations up here. So I'm rearranging that last term, 2/t, as 2t to the -1, and if we differentiate that, okay, and simplify, you're going to get 1 when you differentiate the t, and -2t to the -2 when you differentiate 2t to the power -1. Rewriting this again is going to be 1 - 2/t squared, okay, for that last term. So that's that one. And I think some of you might well have seen, got that in your answer, okay. We need dy by dt, so I'm going to do much the same kind of thing. We take y, we rearrange it into a form for differentiating by bringing that t up. Differentiate it, very similar to what we did over here. So you end up with 1 + 2/t squared. So in order to get dy by dx using the chain rule, I'm going to do the division. And that's the result I get. And I noticed, as I say, quite a few of you were starting to put this answer up. But it did say give your answer in its simplest form. So although this is correct, it's not the simplest form. I call this a stacked fraction. If you go on my website, I've got tutorials there about cleaning things like this up. We will always bump into lots of fractions like this. We've got to be able to handle it, okay? And the way we do that is we tidy this up by eliminating the fractions here. This t squared and the t squared there. We multiply top and bottom by t squared, okay? T squared over t squared is like, well, it is the value 1. And if you multiply a fraction by 1, it's obviously not going to change its value, but it is going to simplify it, okay? So if you do 1 times t squared, you're going to get t squared. 2/t squared times t squared will just leave you with 2. Okay, the t squareds will cancel. And when it comes to the denominator, 1 times t squared is t squared. And -2/t squared times t squared will be -2. So this is what you should end up with. Okay? So I did see some of you guys out there with that answer, and that would have got you the full 4 marks if you got down to there. Okay? So well done for doing that. I think it was Din who came in with the correct answer there. Well done, Din, who was the first one in. Rahima, I noticed you had the unsimplified one, so well done for having a go anyway. Okay, well done to all of you for having a go. Those numerical results though, I kind of think, as I say, you might have been substituting t = 0 at a guess into this maybe, okay? If you did substitute t = 0 in, you're going to get 2/-2, which gives -1. And I think I saw a few of you having -1 out there. So maybe that's what you did. Okay, right, let's go on. And we've got another part to this, okay? And in this part, I'm just going to give you a few moments here. It's not something that you can necessarily write down. Okay, just think about it. We've got here, explain why the curve has no stationary points, and it was worth 2 marks. Okay, so I'm not really expecting you to write down anything for this. I'll just give you the answer and you can tell me whether you got it right or wrong, or whether you're on the right lines. Okay, in a few moments. Let's just give you a minute to think about that. Okay. Just jot down your thoughts. Explain why that curve has no stationary points. Remember, a stationary point is where the gradient of a curve would equal 0. Okay, I hope that doesn't let out too much, give it away too much, but it's where the gradient would be 0. Okay, I see some of you guys are typing in some answers here, which is quite interesting. Yeah, have a go. That's good to see what you've got. Yeah, I think you guys generally have got the right idea here. Obviously, the examiners are going to look for how you've put your answer down, but basically, yes, you're right. At stationary points, we know the gradient dy by dx is equal to 0. Okay, and if dy by dx was equal to 0, it means that the numerator here, t squared plus 2, would have to equal 0. And if you try to figure out the value of t for that, you'd end up with t squared equaling negative 2. So t would be equal to the square root of negative 2. And so therefore there's no solution, no real values. If you do further maths, you would know that the square root of negative 2 involves complex numbers. But we're not going to go down that avenue. From the point of view of this, there is no real solution. Okay, so therefore no stationary points. So yeah, that's good to see you guys generally have got the idea out there for that one. Okay, right, we're going to move on to the third part though of this question, and hope you're ready for this. Okay. Oh yes, I just wanted to bring up one other point, sorry, before we move on to that third part. Just interesting, just to let you know that if you were to sketch the curve, it would look something like this. Okay, just take my word for it. Okay, it would look something like that. And since we're talking about stationary points, we've seen that there aren't any stationary points. You can see this curve doesn't flatten out, okay, at all. There's no maximum or minimum point on it, okay. But one interesting point that I've seen before being asked is, especially on the further maths side, for something like this, and that is, are there any vertical tangents? And if so, what are their equations? Well, when you've got vertical tangents, you would expect the denominator to be 0, so that the gradient is undefined. Okay, and so notice that if you make the bottom, the denominator 0, t squared would equal 2, so t would equal the square root of 2. Okay, and so when that happens, when t equals the square root of 2, you'll get plus or minus root 2. So that's when dy dx is undefined. And if you substitute t equals negative root 2 into here for x, you'll end up, sorry, for t I should say, you'll end up with x being equal to minus 2 root 2. And if you substitute t equals root 2 in, end up with x being 2 root 2. So what does this mean? Well, it means that you've got tangents to the curve, and I'll draw them in, 2 vertical tangents here with the equations x equals minus 2 root 2 and x equals 2 root 2. I just thought I'd put that in passing, okay? Just if, you know, you further maths guys out there were asked a question like that, okay? I've seen things like that come up in papers, okay? So, right, let's just move on to the last part of this question. You've got to you've got to get what that equation that you just saw was, okay? We've got the parametric equations that we were given at the beginning of the question, and it says by considering x plus y or otherwise, find a Cartesian equation of that curve that you just saw drawn there. Giving your answer in a form not involving fractions or brackets. So again, look at that ending here, okay? So away you go, okay? 4 marks for this, okay? So see what you can do with that. Enter your answer in, okay, for that Cartesian equation. So it's always think with questions where it gives you an idea, okay, I would always follow the idea. The or otherwise, by the way, in exam questions is a route that I wouldn't encourage anyone to take. It often is a much longer method. So I've seen questions say hence or otherwise. I'd always pick the hence route because hence is using the bit beforehand, okay? This is a similar kind of question in as much as use the idea x plus y, their hint that they're giving. So Din's coming in with an answer, x plus y equals 2. Anybody else agree with that one? Or have you got another answer? So we're looking for that Cartesian equation. So I'd imagine a Cartesian equation is not going to be a constant. And also, if you looked at that graph I drew on the previous screen, it was curved. There's another clue. Okay, it was curved. So, anybody else coming in with x plus y equals 2 as an answer for that Cartesian equation? How's it going out there? Cartesian equation is one that has just x's and y's in, okay? So I'll drop another clue, okay? You're trying to eliminate t from those two equations that contain x and y, okay? A Cartesian equation is one that has x and y's in and doesn't have that, what we call a parameter, that third variable t in, okay? So it's a good question to do even if you're, at this point, even if you're an AS student, you should be able to eliminate t between these two equations and get a relationship between x and y. Okay, so we've got, I noticed Happy Gaming's got an answer, okay. Again, how are we doing with this out there? Okay, is Happy Gaming's answer correct? Is Din's answer correct? Okay, we want to see some more answers, see what we're getting. Remember, it does say without brackets, okay? Do make sure you read an exam question carefully. Giving your answer, it says in a form not involving fractions or brackets, okay? And I do see the answers, a couple of answers up here with brackets in, okay? So we're not looking for brackets. Okay. This is obviously proving to be harder than I thought for several of you guys. No problem, but it's just a good exercise to do. You're trying to eliminate that t. Add the two equations. Yeah, I can see that, Rahima, that maybe you've never seen a question quite like that, asking for no fractions, no brackets, but we've got to do as we're told, so to speak. Okay, so there we go. Marcus can't get t on its own. Get t. I'll give you a clue, right, at this point. Once you've added the equations together, make t the subject in terms of your x's and y's, and then resubstitute it back into an equation. Okay? So you should find by adding the two equations, you get an equation with t still in it. But you make t the subject and then you resubstitute it back in. I see that, Rahima, you've got y equals 2t minus x. If that is the case, make t the subject. Okay? T will equal y plus x over 2, if that is correct. And then substitute that back into one of your two equations for x or y, and you'll get an equation that involves x's and y's. Okay? Come on, guys, you must be nearly there. Okay, right, go for it. Race is on. I'd love one of you guys to give me the answer. Okay, we're getting some answers maybe coming through. They're not necessarily correct though. Think about that curve I drew. Kieran, you've got I think you've, is it Kieran? No. Okay. An equation's got to have an equals in, okay? Jasmine, I see. Right, okay. Come on, guys. Time's ticking away. Taking a bit longer than I thought. Ah, we have an answer from Sonal. Is it right? Gosh, these are... right. Gosh, this is definitely proving really difficult. Right. Okay, I'll just love an answer to come through. None of you have got it right at the moment. Okay, I'm going to just put you out your misery, okay? I'm going to go through it, but if you keep typing in if you feel that you're going to get it, okay? I'm just going to start to do it. Okay, you should have taken your two equations. I've numbered them 1 and 2, okay? Do as it says, add them together. I hope that most of you did that, and you'll find that the n terms cancel out, and you're just left with 2t, okay? Hey, I just see one coming in, okay, if I'm not mistaken. Is that right? Yes, we have a right answer. Well done, Tosh, okay? Right, okay, so let's just carry on now. You make t the subject here, okay, so divide both sides by 2 and you end up with t equaling x plus 1 over 2. Now you can substitute this back into either equation 1 equation 2. It makes no difference, okay? If you do it properly, you'll get the same answer at the end of the day. I prefer to go into 1 purely because it's got positive values in. Handling negatives can often mean that you trip up, okay? It shouldn't, but it can often be harder to work with. So I've substituted this into equation 1 for t. So you get x plus y over 2, and then you get 2 over this stacked fraction, if you like. So we need to tidy this up. And to tidy this up, I multiply top and bottom by 2 again, like multiplying by 1. I know some of you might say, oh, just turn it upside down and multiply. It's not great at this level to think like that. We're timesing top and bottom by 2, and we end up with 4 over just simply x plus y. Okay, so that's that last term. It says no fractions, okay? So we've got fractions here, so what would I do? Get rid of them. Times through both sides by the 2 and the x plus y. And if you do that, you're going to end up with this result, okay? But we got brackets in it, and we need to expand the brackets, okay? So if you expand the brackets, you're going to get this result, okay? We've got this squaring a bracket again. Square the first term, twice the product. You got xy there when you multiply those together, double it, 2xy plus the last term squared, okay? So just group this up, okay? Rearrange it, group it up. Those 2xy's cancel out. 2x squared minus x squared gives you x squared. Subtract y squared from both sides. You've got x squared minus y squared. I've left the 8 on the other side, but I noticed that some of you have brought the 8 across, no problem, made it equal 0. So, well done for getting it. Tosh, teacher, but I don't know, are you a teacher? I don't know. If you're a teacher, well, I would expect a teacher to get it right. But there we go. All right, so well done for doing that. Proved quite a hard one. So I hope you're able to see your way through that now, though. All right. Anyway, look, we're running 40 minutes. Okay. Do you want another question? For me to go through another question? Let's just see what the consensus is. Just let me know if you'd like another question. Just type in yes or no, okay? And we'll see what happens, okay? Okay. Do you want me to do one more question? I had 3 out here, okay? All right, okay, good. Well, thank you for sticking with this, okay, guys? Right, we're going to go for this last one, okay? And the last one is this one here, okay? It's an A-level one. If you're an AS student, you should get some value from this, I hope. But even sit back and see what happens. But solve this modulus equation, okay? The modulus of 2x minus 1 equals the modulus of x plus 3. We got 3 marks for this. And I will say that for doing this kind of question, there's several, well, a couple of ways I'm going to show you how to do it. One's quicker than the other, okay? You should be familiar with both methods, though. Now, as I say, some of you, this is most probably going to be new to you. What do those lines mean? I see coming up. The lines mean, it's called a modulus, okay? And it represents a value that's positive. So, for instance, like x was minus 3, for instance, and if I put 2 times minus 3 in here, that would be minus 6, minus another one, that's minus 7. But when you put straight lines down here, the modulus, minus 7 is converted to a positive value, so it is 7, okay? I can't say too much here because it's not really a full tutorial on that, okay? Do check out my videos on ExamSolutions.net. Look under, I can't remember now, I think it's in the A-level section, and what was it? algebra and functions 2, and you should find modulus equations. Okay, there. Right, we seem to have some answers coming through. Okay, by the way, I can see that someone's put Marvinus put, so can I just put it on a graphical calculator? Will I get marks? Generally, no. Okay, you should show some form of working. Okay, if you trip up, no one's going to know what you've done, really. Okay, anyway, I see some answers coming through, and are they right? Yes, we have some right answers there. Okay. And it looks like, if I'm not mistaken, the first one in with a correct answer is Papua 002. X equals 4, x equals minus 2/3. Well done, guys, for getting that. Okay, so let's just go through quickly so we can wind this up. Okay, it's taking a lot longer than 40 minutes. Okay. One of the methods is squaring methods. Okay, when you've got two terms with modulus signs around them, a squaring method is very useful. Okay, makes them positive values. So again, we've got this squaring idea of brackets, so you should be familiar with that. I would go straight to this answer on this bottom line rather than writing out separate brackets, but that's up to you, okay, if it helps. There you go. We've got a quadratic equation. We need to rearrange it, and if you rearrange it, make it equal to 0, you're going to get 3x squared minus 10x minus 8 equals 0. Factorize it in the usual way. You get your two factors, put each of those factors equal to 0, and you can see that by rearranging it, x equals minus 2/3 or x equals 4. Okay, so well done, guys, for getting that. So that's one way. The other way, which you will be called upon to use on occasions, and so it's worthwhile just illustrating it here now, is to draw a graphical method. Okay, so we're going to start with drawing the graph of y equals the mod of 2x minus 1. It's this solid red line here. I've just done this dotted line down here purely because if you were asked to draw the graph of y equals 2x minus 1, okay, it would be a line with a gradient of 2, the m value would be 2, crossing the y-axis, the y would be negative. But remember that when you're doing modulus graphs, it comes down to the x-axis, it hits the x-axis and is a reflection of this dotted line across the x-axis. So it's going to go up here. So it crossed the y-axis at -1, so you get a reflection up here of 1. Okay, and it touches the x-axis when y is 0, and that's going to be when x equals half. Okay, so important to get that line in there. Okay, now you're going to need to draw on the graph of y equals the mod of x plus 3, and it's going to look something like this. This would be the line coming right the way down here of y equals x plus 3. Okay, it's a straight line with a gradient of 1, so not as steep as the this line here with a gradient of 2, so it will intersect it. It will intersect it here and here. And similarly, it's going to bounce off up in this direction. But this line is going to intersect this line. I've only got two solutions, and they're going to come from these points which I've labelled A and B. And to get those 2 points, let's start with this one here, because it's very easy, the one for A. We've just got to solve simultaneously the equation of this line with this line down here. In other words, the line y equals 2x minus 1 with y equals x plus 3. So we have got this set of simultaneous equations. I've just equated them together, okay, and you'll see that x equals 4. So if I came down here, this value on the x-axis would be 4. Now for this one here, B, we've got to be a bit more careful because we've got this line intersecting this line. Now this line has equation y equals x plus 3, but this line, okay, would have the negative of this gradient. Okay, it would be minus 2x, and it would intercept at 1. You might think of this as just putting a negative in front of all of 2x minus 1, and you'll be perfectly correct, okay? Minus 2x minus 1, and that would give this line as minus 2x plus 1. You've just got to equate those together, minus 2x plus 1 with x plus 3. Solve that by rearranging it, and you'll end up with minus 2 equals 3x, and therefore x equals minus 2/3. So it involves a bit more work there, but you should be familiar with drawing modulus graphs. Okay, we're going to need it, or you're going to need it in other questions. So something not to be dismissed. Okay, right, well, I'll come back on screen now, okay, as usual. Okay, so that's taken quite a long while actually, 3/4 of an hour, just over, but again, as usual, thanks for sticking with me, and hope you got some good value out of that one. I can see thanks coming in from quite a lot of you guys. Yeah, thank you for, as I say, for coming along. And what's on the agenda tomorrow? What is it tomorrow? Thursday. I've got stats for you. Okay, so again, I'm going to try and figure out some questions that we can do fairly quickly as a group, and we'll have some AS and A-level stuff on. Okay, so yeah, that's on the agenda, and we're back to pure maths again on Friday, and again, it'll be much the same kind of thing from exam questions. So just to say, thanks to Michael again from Mere Maths Tuition. If you joined us later in this, just to remind you that if you've got brothers, sisters out there who are doing GCSE, or yourselves might want to step back and look at some GCSE work, Michael is stepping in on Monday next week, Wednesday and Friday, same time, 10 o'clock. Monday he's going to be doing some algebra with you, live streaming. Wednesday, shapes and geometry, and on Friday, stats and probability at foundation and higher level. Okay, so there'll be mixed questions. So brothers and sisters out there, or pass the word around. Let's see if we can have quite a crowd of people coming on. All right, so yeah, okay, so that leaves me just to wind off now. Okay, so hopefully see you guys tomorrow. Have a good day. Bye for now.